January 23, 1961. Over Goldsboro, North Carolina, a U.S. Air Force B-52 bomber broke apart in midair. On board were two Mark 39 thermonuclear bombs, each with a yield of approximately 3.8 megatons. That's more than 250 times the power of Hiroshima. The bombs fell toward a quiet farming community. One deployed its parachute and went through almost its entire arming sequence. The other slammed into the ground and buried itself deep in the mud. Declassified documents later revealed that 3 out of 4 safety mechanisms on one bomb failed. Only a single low-voltage switch prevented detonation. Had it exploded, the blast could have devastated eastern North Carolina. Fallout could have reached major cities along the East Coast. This was not a Soviet attack. There was no war, just an accident and 2 hydrogen bombs falling on American soil. In 1961, the United States was in the middle of the Cold War. Tensions with the Soviet Union were escalating. Just months earlier, the U-2 spy plane incident had shattered fragile diplomacy. Nuclear war was no longer theoretical. It was being planned for. To guarantee a rapid response in case of a Soviet first strike, the U.S. Air Force operated continuous airborne nuclear patrols. The program was known as Operation Chrome Dome. Strategic bombers armed with thermonuclear weapons flew 24 hours a day, fully fueled, fully armed, ready to strike. On January 23, 1961, a B-52G Stratofortress took off from Seymour Johnson Air Force Base in North Carolina. Its mission was routine, an airborne alert flight along the Atlantic coast. On board were 8 crew members and 2 Mark 39 Mod 2 hydrogen bombs. Shortly after midnight, a warning light appeared in the cockpit, a fuel leak in the right wing. At first, it seemed manageable, but within minutes, thousands of pounds of fuel were pouring out every hour. The aircraft was ordered to return to base. As it descended, the structural integrity of the wing began to fail. Fuel imbalance created extreme stress. At approximately 2 a.m., the right wing tore apart. The aircraft broke into pieces at over 9,000 feet. The crew ejected. 5 survived. 3 were killed. As the bomber disintegrated, the bomb bay doors opened. The 2 thermonuclear weapons separated from the aircraft. They began falling toward farmland near Goldsboro, North Carolina. Below them, the town was asleep. What followed would become one of the most serious nuclear accidents in U.S. history. When the B-52 broke apart, both Mark 39 Mod 2 thermonuclear bombs separated from the aircraft. But they did not fall the same way. The first bomb deployed its parachute. That detail would later prove critical. The Mark 39 was designed for high-altitude delivery. When dropped intentionally, a parachute would slow descent and allow the bomber to escape the blast radius. As the bomb descended over rural Wayne County, its internal systems began responding exactly as if it had been released in combat. The barometric sensors detected altitude change. The arming sequence initiated. The parachute deployment pulled the arming wires free, a normal step during a combat drop. Internal batteries activated. Capacitors began charging. According to later analysis by Sandia engineers, 3 of the bomb's 4 safety mechanisms were bypassed during the sequence. The low-voltage ready safe switch was the final barrier. The bomb landed upright in a field near the town of Faro, North Carolina. Its parachute tangled over the body of the weapon. When the recovery team arrived, they did not find a shattered device. They found a largely intact thermonuclear bomb, still connected to its firing circuitry. The safe arm switch was set to arm. Years later, a declassified 1969 Sandia report would conclude, "The Mk-39 Mod 2 bomb came dangerously close to detonating." The report also noted that only a single low-voltage switch prevented full detonation. That switch was not a complex fail-safe system. It was a relatively simple electrical component. Without it, the weapon would likely have completed its firing sequence. However, and this is important, the bomb did not detonate. The final firing signal was never sent. But the margin between accident and catastrophe was thinner than the Air Force publicly admitted at the time. The second Mark 39 did not deploy its parachute. It fell freely, without drag, without stabilization. It struck the ground at high speed in a muddy farming area near Big Daddy's Road, outside Goldsboro. The impact was violent. The outer casing shattered. Conventional high explosives inside the weapon were damaged, but the thermonuclear physics package, the uranium and plutonium components, did not detonate. Instead, the bomb drove itself deep into the waterlogged soil. The site quickly turned into a recovery operation. The Air Force secured the area. Engineers began excavation. The tail section was recovered first. Fragments of the bomb casing were found approximately 20 feet below ground. But the deeper they dug, the worse conditions became. The soil was saturated with groundwater. Excavation walls collapsed repeatedly. Heavy equipment sank into mud. At least one of the bomb's secondary stages was located and removed, but not all components were successfully recovered. According to official Air Force statements, most of the nuclear material was retrieved. However, part of the bomb, including some uranium components, remained buried due to safety and engineering limitations. The government later purchased a permanent easement on the land. Digging deeper than a specified limit was restricted. To this day, small amounts of non-recovered material remain at the site. Importantly, there has been no confirmed evidence of dangerous radiation levels at the surface. Periodic monitoring has not shown a public health threat, but the fact remains: a thermonuclear weapon impacted American soil. Part of it is still there, buried under layers of dirt. Not armed, not active, but never fully removed. For years, the Goldsboro incident was described as a broken arrow, a military term for an accident involving nuclear weapons that does not create the risk of nuclear war. Public statements minimized the danger. Officials maintained that the weapons were safe. But in 2013, newly declassified documents added nuance to that claim. Investigative journalist Eric Schlosser obtained a 1969 internal report from Sandia National Laboratories. Sandia was responsible for nuclear weapons safety engineering. The report analyzed the Goldsboro accident in detail. Its conclusion was direct. The parachute bomb had progressed further into its arming sequence than previously acknowledged. Of the 4 independent safety mechanisms designed to prevent detonation, 3 had effectively failed during the fall. The arming wires had pulled. The batteries had activated. The ready safe switch had moved to arm. The report stated, one simple dynamo technology low-voltage switch stood between the United States and a major catastrophe. That line would later be widely quoted. However, context matters. The Mark 39 Mod 2 was a complex thermonuclear weapon. Detonation required a precise sequence of electrical and mechanical events. The final low-voltage switch prevented power from reaching the firing circuit. Had that switch short-circuited, detonation would have become far more likely, but whether full nuclear yield would have occurred remains debated among engineers. Some experts argue that other environmental factors might still have interrupted the chain. Others maintain the risk was extremely serious. What is clear is this: the weapon was not in a fully safe condition when it landed, and internal safety assumptions at the time were later revised. Following incidents like Goldsboro, the United States significantly redesigned nuclear weapons safety systems. Modern warheads incorporate stronger one-point safe designs, enhanced environmental sensing devices, and multiple independent barriers. Goldsboro became a case study, not of conspiracy, but of design vulnerability during an era of rapid nuclear expansion.
On paper, the Goldsboro incident is classified as a broken arrow. No detonation, no radioactive explosion, no war. But that label does not capture the full weight of what happened. 2 3.8-Megaton thermonuclear weapons fell on American soil. One completed nearly its entire arming sequence. 3 safety mechanisms failed. Only a single low-voltage switch prevented electrical power from reaching the firing system. Had the parachute bomb detonated at full yield, the immediate blast would have devastated a large portion of eastern North Carolina. The fireball alone could have reached over a mile in diameter. Severe destruction would have extended for miles. Radioactive fallout would have depended on wind patterns. Contamination could have spread across state lines. Major East Coast cities would not have been vaporized, but the economic, environmental, and political consequences would have been enormous. There is no confirmed evidence that the Soviet Union would have automatically interpreted the explosion as a deliberate strike. However, in 1961, during peak Cold War tension, any unexplained nuclear detonation on U.S. territory would have created global alarm. What makes Goldsboro historically significant is not what happened, it is what the internal safety review revealed afterward. The accident exposed weaknesses in nuclear weapon design. It forced engineering reforms. It led to stronger safety mechanisms in future warheads. It became a quiet turning point in nuclear safety policy. Today, the farmland near Goldsboro looks ordinary: fields, roads, soybeans. Beneath that soil lie remnants of a Cold War accident, not armed, not active, but a reminder. Nuclear weapons were not only aimed at enemies, sometimes they nearly destroyed the country that built them. This is not a conspiracy theory, it is a documented accident. Declassified.